This video gives a revision on stoichiometric calculations. For stoichiometric calculations, I need to first know how to calculate number of moles. So number of moles is equal to mass of the substance, maybe the element or the compound, mass of the substance divided by molar mass. So molar mass, when I consider so this is how you are going to see the relationship, how to rearrange the equation. So we say number of moles is N, mass is small m, molar mass is Mr. So N, M, Mr. So it is going to be division and multiplication. So you can easily rearrange this equation. Then again I can use another formula for number of moles calculation. This is for the gas. When the gas is given with the volume. So volume of the gas, please be careful, it is for the gas volumes. Volume of the gas divided by 24 decimeter cube, because 1 mole of any gas under room temperature and pressure conditions, it occupies only 25 decimeter cube of volume. So number of moles is equal to volume over 24. It's a division, then it is multiplication. If I have concentration for the solution, so again I can calculate number of moles from concentration. So there are different three scenarios I am talking about. One is when the mass is given, the other one is when the volume is given. Now the concentration is given. So concentration multiplied by volume of the solution divided by 1000, because volume of the solution may be given in centimeter cube, so I need to convert it into decimeter cube. Please be careful, gas volume is different from volume of a solution. So again concentration is equal to number of moles over volume. So that's why rearranged formula, number of moles is equal to concentration multiplied by volume. So let us take some simple examples to understand and how to use the formula. We'll just learn how to use the formula. Let me take one example. Calculate the number of moles of carbon dioxide in 72 grams of it. So 72 grams of carbon dioxide contains how many moles? That's what here asked. So first I need to find the molar mass of carbon dioxide, because that is not given. Molar mass of carbon dioxide I can find from the periodic table. If I look at the periodic table, carbon has a mass of 12 and oxygen has the mass of 16, but 2 oxygens are present, 2 times 16. So if I do it in the calculator, I will get 44 grams per mole. This is the molar mass of carbon dioxide. Then I use the first formula of this video, number of moles of carbon dioxide, which is equal to mass of the carbon dioxide given is 72 grams. Molar mass of carbon dioxide is 44 grams per mole. So when I divide 72 by 44, 72 divided by 44, what I am getting is, I am getting 1.636, so I would say 1.64 moles. This is how I calculate the number of moles from the mass given to me. Let me use this in the calculation of stoichiometry. How will I find out the limiting reagent? How will I find out the how many moles of product or reactant required or formed, we need to do that. So I am taking another example. How many moles of iron can be made from Fe2O3 by the use of 16 moles of carbon monoxide. 16 moles of carbon monoxide in the following reaction. So they are asking how many moles of iron can be made, that is, iron can be produced. So the reaction is given as Fe2O3 plus carbon monoxide gives Fe plus carbon dioxide. So the balancing equation is 3, 2 and 3. So this is a balanced equation. So what is given to me? 16 moles of carbon monoxide they are using. I want to know how many moles of this. So I need to know number of moles of iron made. How will I get? I can take the ratio. So what is the ratio? 3:2. 3:2. What I am having? 16. So I need to find this. So how will I do this? I have to get the question mark, or else this is x. So what I am having is 3x is equal to 2 times 16. So x is equal to 2 times 16 over 3. So let me do it here. 2 times 16 over 3, which is equal to 10.67 moles of Fe. So it is the simplest way of doing it. You can simply take the ratio and you can find the number of moles. If you are known to number of moles, if they are asking mass, you can multiply this by molar mass, you will get the mass. So let me take another example which can be used with the limiting reactants. How to get the limiting reactant? So what is a limiting reactant? The limiting reactant is the one which is present in limited quantity, not in excess. So if they are given some masses, if there is a balanced equation given, how will I get the limiting reactant? How will I determine the limiting reactant? So I am going to take another example. If 20.0 grams of calcium carbonate is treated, 20.0 grams of calcium carbonate is treated with 20.0 grams of HCl. How many grams of CO2 can be produced? Of CO2 can be produced. So this is the question. You are given the balanced chemical equation: calcium carbonate solid, HCl aqueous gives calcium chloride aqueous plus H2O liquid plus carbon dioxide gas. This is what the equation given. You are given the masses of both the reactants. 20 grams of calcium carbonate, 20 grams of HCl. We need to know whether they are in an appropriate proportion or something is in excess, something is in limiting. So to know that, first I need to find the number of moles of the reactants. Number of moles of calcium carbonate. So immediately I need molar mass of calcium carbonate. So when I want to go for molar mass of calcium carbonate, molar mass of calcium carbonate, I will be using the periodic table. 40 is the mass of calcium, 12 is the mass of carbon, and 16 is the mass of oxygen. So I have this. So I have 52 plus 48, 100 grams per mole. So number of moles of calcium carbonate will be 20 divided by 100. 20 divided by 100 is 0.2 moles. If I go for number of moles of HCl, number of moles of HCl, which is equal to 20 divided by, I need to know the molar mass of HCl. The molar mass of HCl is 1 plus 35.5, which is 36.5 grams per mole. 36.5 grams per mole. So 20 divided by 36.5. So I am getting 0.55 moles. So we need to use again the ratio to get number of moles of requirement, or how much is required. So let me do that also. So as per the equation, the ratio is, when I consider calcium carbonate is to HCl, it is 1 is to 2. So let me take 0.2. So when it is 0.2, what will be x? This x will be equal to 2 times 0.2 divided by 1, which is equal to 0.4 moles. This is for HCl, 4 moles of HCl. This is what I need. So how much HCl I am having? I am having 0.55 moles of HCl. I am having out of 20 grams, I have 0.55 moles of HCl. But I need only 0.4. So HCl is in excess because it is available in more. This is the available number of moles, and this is what required for 0.2 moles of calcium carbonate. So this is available. So this is in greater quantity when I compare it to the required. So this is the excess reagent. Who is the excess reagent? HCl is the excess reagent. Then who is limiting reagent? The limiting reagent is calcium carbonate. So limiting reagent is calcium carbonate. So now they are asking how many grams of carbon dioxide produced. Now I need to calculate the amount of carbon dioxide produced with respect to the number of moles of calcium carbonate. This is the number of moles of calcium carbonate I need to find, because this is in excess. This is not going to stop the reaction. The limiting reagent is the one which is getting completed first, and that will stop the reaction. Further reaction will not happen because calcium carbonate will be consumed completely. So when I consider calcium carbonate 0.2 moles, again I am going to take the ratio to calculate the mass of carbon dioxide produced. Calcium carbonate is to CO2. When I consider 1 mole of calcium carbonate gives 1 mole of carbon dioxide. So 1 is to 1. So 0.2 will be the same 0.2 moles. So mass of carbon dioxide will be, again I use number of moles multiplied by molar mass. Number of moles 0.2. Molar mass at the beginning of this video I found it is 44. So which is going to be 8.8 grams. So I hope you understood how to find out the limiting reagent, and using that limiting reagent how to find out the mass of a product formed. I hope these two helps you to understand the calculation of mass of the product formed and identify or determine the limiting reagent. I will do another video to help you in calculating the concentration of the solution when the titration values are given, and as well I will help you in the calculation of gas volumes. So those two will be given as a separate video. You can watch that also. You can improve your concepts on titration calculations, that is stoichiometric calculations of titration. Thank you for watching.